All right, moving into our third page of the test review, halfway through here. Answer the following questions about this function h of x is equal to negative 2x minus 8 over x squared plus 4x minus 12. First off, is the point negative 2, 0 on the graph here. So the way I can test this is if I plug in negative 2 for x, do I get 0 out as the solution in the end? So if I plug in negative 2 for the x, I'm going to get negative 2 times negative 2 minus 8 in the numerator. The denominator is negative 2 squared plus 4 times negative 2 minus 12. And really all that matters is the numerator here. If I plug in that negative 2, this negative 2 times this negative 2 will give me 4. So I get 4 minus 8 on top, which is going to be a negative 4. Now along the bottom, I'm going to get some number here, but it's not going to give me 0. I'm going to get negative 4 over some value. I mean, if I work this out, this is going to be a 4 minus an 8 minus a 12. So we're looking at negative 16. We're looking at essentially 1/4, but we did not get 0 out of this. So the answer here is no. Next question. What is the domain of h of x? Give your answer using interval notation. So the domain focuses on the bottom of our function with this rational function. When you're looking for the domain of a rational function where you have x's in the denominator, you're not concerned about the top at all, just the bottom. What would make the bottom 0? You can have negative infinity to infinity. You could have essentially all real numbers except for the numbers that would make the bottom 0. So I want to see, well, what numbers would make x squared plus 4x minus 12 equal to 0. So I'm going to factor this. To get that x squared, it has to be an x and an x. For 12, I've got 6 and 2 as an option. They multiply to be 12. I've got 3 and 4 as an option. They multiply to be 12. I'm going to go with 6 and 2 because they can subtract to be a positive 4x. If I have a positive 6 and a negative 2, they would multiply to be this negative 12 on the end, and they would add to be this 4 in the middle. And so the results from here would be negative 6 and positive 2. Those two numbers using the 0 product property would make the denominator 0. You would have a number over 0, and the function would be undefined there. So my domain would be from negative infinity to infinity, but excluding these numbers. And to do that in interval notation, I would say we go from negative infinity to negative 6, unioned with negative 6 to 2, unioned with 2 to infinity. So I'm going from negative infinity to infinity, but with a gap at negative 6 and a gap at 2. Third and final part of number 8, what is the 0 of the graph? The 0 is found by setting the function equal to 0 and solving. So I'm going to take negative 2x minus 8 over x squared plus 4x minus 12. Set that equal to 0. I can think about a 0 over 1, and that way I can cross multiply. So I'm looking at negative 2x minus 8 times negative 1. That's just negative 2x minus 8. Then 0 times x squared plus 4x minus 12 is still 0. And so I just have to solve this. So negative 2x minus 8 equals 0. I can add an 8 to both sides. So negative 2x equals 8. Divide by negative 2. And x is equal to a negative 4. And that's my 0. Number 9, another domain question. Give the domain of this function k of x that's equal to the square root of x minus 4. So with these rationals, you want to see what makes the bottom 0 and avoid those numbers. For these square roots, you want to take what's underneath the square root and set it greater than or equal to 0. You don't want a negative under the square root because that leads to imaginary numbers, not real solutions. So we say those imaginaries aren't in their domain. So with these square roots always greater than equal to 0, I'll add 4 to both sides. So x has to be greater than or equal to 4. Now that's not quite an interval notation. That would be from 4 to infinity. 4 gets the square bracket because of the equal to component, and we're looking at numbers greater than 4, like 5 and 10 and 20 and 37, all those numbers all the way up to infinity. Number 10, determine the equation of the line below. Put the equation in slope-intercept form, giving your slope and intercept as integers or reduced fractions. So that slope-intercept form is y equals 2 mx plus b. B is usually where you want to start. It's where the graph intersects the y-axis. That's right here. It looks like it might be at 2, but if I zoom in a little bit, we can see it's crossing just above 2. So maybe it's 2.1, maybe it's 2.2. I'm not quite sure. So what I can do is I can find a point that is on the grid, like this point, -1, 3, or this other point, which is 3, 0. And I can begin by finding the slope, so the rise over the run. So to get from the point on the left, the -1, 3, to the point on the right, the 3, 0, you've got to go down 3 units. You've got to run to the right 4 units. So my slope here is y equals -3/4 x. My rise over my run, I would have to go down 3, I'd have to go to the right 4. So my slope is -3/4 plus b. And now to find the b value, I can plug in one of my 2 points for x and y and solve for b. So I'll go with this point 3, 0 because it's nice to work with 0 a lot of the time. I can plug in 3 for x and 0 for y and solve for b. So 0 for the y value, -3/4 times the x value was 3 plus b. So I get 0 is going to equal to -9/4 plus b. To get b by itself, I'm going to move this 9/4 to the other side. Just switch sides and switch signs. So b is equal to a positive 9/4. And now I know that my equation of this line is y equals 2 -3/4 x plus 9/4. Again, I've used reduced fractions here. I didn't go with any decimals. So this is probably a good place to stop this video. I'm probably low on time. I'll move to number 11 in the next video.